Hello, grade 8s. Okay, so I do want you to watch through the reasoning just of the first question and then just jump around to the questions that you need help with. So you'll see I've given you feedback, individual feedback on your questions, but in it I might also have just referred to, just have a look at this video and jump to that bit because that might be helpful. So we got our questions we're going, and we did the first one in class, and I just want to reinforce, so hang on here, and reinforce this idea. Well, we're trying to solve what A is, and we've got a number of tools in our toolkit. The idea of we know different types of triangles, and we know a few properties of triangles. And we're going to use those to try and figure out these unknowns. So here we said in class, yeah, the idea is, okay, well, we know that they add up to 180, so we go, 110 plus 30 is 140, and we subtract that from 180, so we get 40. Now, what we're doing as well as this is we're practicing how we're going to put across this thinking. So you've got this thinking, and one of the key skills in mathematics and in life, I would argue, is not just, oh, well, you know something, but how do you convey that, and how do you justify it with reasons? And geometry is just fantastic for this and developing this sense and this logic. So in this case, we said, well, we know they all add up to 180. Well, that was a reason. So we put down the reason here and we said sum of angles in triangle. So we showed our reasoning. And then we said, well, we needed to add these two up and then subtract them from 180. So we've shown that here in a statement, as opposed to just scribbling all over the diagram. Now we've taken it to a next step and been able to convey our logic to go, oh, so if we added these three, we would get 180. So if we added A and what were these two? 140. That's what we're doing and thinking, and now we've put it in an equation. So I'm really trying to reinforce it is both of those things. I'm not saying this is the only way to do it, but it's about showing your reasoning really well. Okay, so we've got that point. So in the second one we said, oh, well, we saw these marks here, so we knew it was an isosceles triangle. What do we know about isosceles triangles? Well, these two sides are equal and these two angles are equal. So A must be 65. So that maybe the one extra step we've added here is not just gone A equals 65. We've said, oh, isosceles triangle. That's why we know it's the same, because we've recognized the type of triangle it is. So that's that extra step. Then that's as far as we got to in class, and the rest you were having fun with at home, right? So then we needed to work out B. Well, now it looks like the first question. We've got two angles and we need to find a third angle. So for our third angle for B, let's do it here. I'm going to rub out this bit and say, cool, well, we're going to be adding up all of them and getting to 180 again, right? So our reason is, well, we're summing the angles in the triangle. That's our reason. And our statement is, well, if we add these three, we get 180. So these two are 65. So 65 plus B. When we add them all together, we get to 180. You're probably already going, well, 65 plus 65. Well, add those together, you get 130. So we may as well show that step of our logic, and it fits in with the equation. Well, 130, 65 and 65 is 130. While I'm on it, you'll notice I put the degrees, and then I started sometimes not, sometimes putting them in. We do not need them while we're making the calculation, but in our final answer we'll show our units. I think if you're working with centimeters, you don't put centimeters all the time, but in the end you put it. So the same with the degrees. You don't have to put them for every step. Okay, and then you said, well, we needed to subtract 130 from 180. Again, let's just show that step. Minus 130, minus 130. Remember, illegal device. Numbers we should be able to work with them and be comfortable with them. So, well, 18 minus 13 is 5. But add the 0, because we're multiplying by 10. So it's 180 minus 130. And that's what B is, degrees. Okay, so there we go. So let's keep going onwards, upwards. Next one, third question. We've got 45. A right angle triangle. Oh, immediately I might think Pythagoras. But Pythagoras doesn't help us with angles. Pythagoras helps us get side lengths, but not with angles. So nothing directly with Pythagoras. Now there's a later question that's going to involve Pythagoras and angles sort of, but you'll see their side lengths. So A, 45. Oh, but what does this symbol here mean? Well, it looks like a square. It looks like it's a right angle. In other words, we know that this is just another way of writing 90 degrees. Just a nicer, neater way of writing 90 degrees. Oh, 2 angles, we need to find the third angle. I feel like this is something that we're going to do quite often. So we can say, well, we're going to sum the angles of sum of angles in triangle. Remember my pet peeve, no apostrophe. And so if we've got A and we add it to 90 and 45, we're going to get 180. Okay, maybe we do this. I'm going to be naughty. No, I don't know naughty, but I'm going to do this in one step. We go 90 and 45 is 135. Okay, and we need to subtract that from both sides. So that leaves with 135. What are we left with? 45. That seems to make sense. 45, because I worked out from the equation. Or I've gone, well, if that's 90, that's 45. Well, if that's 90, these two together must make 90. So that must also be 45. So what type of triangle is this? Well, also happens to be an isosceles triangle. So this is an isosceles triangle, and it's a special isosceles. It's a right-angled isosceles triangle. So this one, it's a right-angled triangle, but not just any triangle. It's a right-angled isosceles triangle. That's quite exciting. This is just an isosceles triangle. And yeah, it looks like another isosceles triangle in 4 because of these check marks here. So if those are the same, these two must be the same. Okay, so how are we going to get there? How are we going to show our working? Well, these two must be equal. So I'd be tempted to write that. And I say tempted because there are always going to be a few ways that you could do this. And I really want to reinforce this, that you're just showing your logic. So just because I'm writing it one way, it doesn't mean that's the way to do it. It's just the one that jumps out to me, but you might well write it in a different way that makes as much sense. And hey, you've probably got feedback from me going, tick, 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 that looks great, and you did it in a slightly different way. So I think it's just such an important thing. So don't look at a memo or something and go, that's the way. But what jumps out to me is it's an isosceles triangle, so those two are the same. So I want to start by just saying A equals B, isosceles triangle. That's something I noticed. I want to show to whoever's reading the work. You, at this case. So I want to show you that I know that. So in other words, that's also A. So if these two things are A, well, that's quite cool, because if I add them in 42, it's going to be angles in a triangle, right? So I'm going to go, well, A plus B, but they're the same. So A plus 42 is 180. Or B plus 42 is 180. And I know that because sum of angles in triangle. So a question here. Why am I writing sum of angles in triangle when I wrote it up here? See, this needs to be an ed puzzle, right? But I know we each are different places. So I'm writing it because this reason relates to this statement. So when I make this statement, I've got this reason going for it. Not this reason here, up top here. Well, when I made this statement, I had this reason going with it. So for the statement, the reason goes with it. And we're growing into this. I know this is new. We've used to just kind of working out, and we're trying to just show our logic more and more, not just, hey, you figured it out, that's cool. Yeah, you figured it out, but you've shown it as well. Okay, so in other words, 2A plus 42 is 180, right? Two of those, they're the same, plus 42 is 180, or A plus A is 2A. So the two are working together here. Look at our algebra. A plus A is 2A. Or, hey, two of those angles is 2A. Keep the two going. Okay, so we need to subtract 42 from each side. So 2A equals, I'm just going to show that, why not? Minus 42 minus 42. 180 minus 42. Well, 180 minus 40 is 140. And then subtract another 2. So 138. You see, we're trying to use those skills from day 1 where we started doing those ways. Okay, well, we just want 1A. So if 2 of them are 138, we need to divide it by 2. And how that matches with the algebra is, divided by 2, we're dividing by that number in front of the A that we call the coefficient. Okay, so 2A, so that's A, 138 divided by 2. Well, 140 divided by 2 is 70. So this must be 69, because we've taken kind of one of those 2's off. Okay, maybe that's one way to think about it. Cool, so we're there. Degrees. You're going to have to keep catching me on the units. I'm terrible at forgetting the units. Okay, let's do question 5 for this video and then put the next question in the next video. This question 5, I think, looks almost the same as question 3. I think we had to identify these triangles as well. So question 4, well, this looked like an isosceles triangle. Oh, and also A equals B. A is 69, so we also should say B is 69 as well. So we show that. Okay, so for this one, well, it's right angled. So again, A plus 30 plus 90, A plus 30 plus 90 equals 180. Sum of angles in triangle. And we can work out, therefore, A equals, well, that's 120, so we need another 60 to get there. Or, if that's 90, these two must be 90 between them, so that must be 60 degrees. Okay, let's leave it at that. Question 6 comes to you in the next video.